Hello, scholars. This is Dr. Oji. I decided to make this video to explain to you my expectation for this final project, which is the project that will require you to construct a P chart for a choosing company. I'm going to do an example with my own question. Then you can watch the video and use it as a guide to complete the project. Or alternatively, you can follow the directions that I provided in the project requirement to complete the project. So either you follow my video, and then do your own project, or you follow the directions. Remember, the video is for my project, my own question. You have your own question for your project. So you can watch the video and follow it to complete your own question, not my own. If you complete my own question, if you do the one I'm doing in this video, you're not gonna get credit. The video is for you to use as a guide to complete your own project question, not my own project question, okay? All right, let's start. Now, this is my question, the question I'm giving. My question is this, it says, for the, this company is called the Spotless Sheets Constructing. Now it says you are required to construct a P chart and interpret it for this company. Now, if you look at the project objective, say that the objective of this project is to help students apply statistical process control methods, specifically the P charts, to monitor and analyze defect rates in a textile production setting. Now, this is for my own company. So the student will use Excel to simulate daily quality control data, calculate the required statistical metrics, and then construct a P chart, and then assess whether the production process remains within acceptable quality control limits or not. So look at my company here. The name of the company is Lean Tech Textile Incorporated. It is a medium, if you can see this, yeah, that's it. It is a medium-scale manufacturing company based in South Carolina, and specializes in producing luxury cotton bed sheets for hotels and retailers across US. Now, due to the high quality expectations of its customers, Line Tech has implemented a rigorous inspection routine. Each day, a fixed number of bed sheets are examined for defects such as stains, holes, weak stitching, or even uneven hems. Now, to maintain a high standard of consistency, the company uses a P chart to track the defective proportion and take corrective action. Now, look at the basic assumption that each day, 150 bed sheets are inspected. That is their sample size. So now you are given a specific sample size in the project question. I gave you a specific sample size. Use that. Mine is 150. Don't use mine, okay? The inspection is conducted 20 consecutive days. You are given that one, you have two. And number of defective sheets will be randomly generated using Excel. So I want you to generate the defective sheets using Excel, okay? Then the data will involve attribute defects. Sheets are either acceptable or not acceptable. The manufacturing process is initially assumed to be in control unless shown otherwise by this. So you are required to, based on this assumption, to calculate the control chart. You are given how many samples that have been inspected each day for 20 consecutive days. And then you have to generate the defect number of defects using Excel a random number generator for random number formula, run between basically. And the data involve attributive defects and manufacturing process. So yeah, with this is mine, you have yours. So let me get you started. First of all, let me write down what they want It says how many patient that is sample size that are inspected each day is 150 bed sheets. And then how many days? Number of days. Okay, you can see that it's 20 consecutive production days. Okay. Now I will take you to Excel where I can now generate my data set. So hit Excel, have is right here. Once you get there, you can put the day, put defective items, put the sample size, put the then with that you can now calculate the rest of this. With all this basic three information, 1, 2, and 3, you can now calculate this proportion, center line, upper control limit, and lower control limit. So it's basically you said it's day 1 to 20 days. So I'm gonna put number of days at 20. See, it's 1 here. If you like, you can type it all the way down to 20. Or if you like, you can use a simple Excel formula to put it. Plus 1. What I did was I put equal sign here, click on the first number, add 1 to that, then press the enter key. Then I can now drag it down to 20, since it's for 20 consecutive days. So I drag it down to 20. Or alternatively, you can type them in manually. Type 1, type 2, type 3, all the way to 20. Now the defective, they want you to generate it, number of defective bed sheets out of 50. So to do that, we're gonna use this formula. Let me write the formula here so you can see it. It is called equals round between. Okay, it's an Excel formula that we use to generate random numbers. Let me make it bigger. In my own case, I'm gonna use round between 5, 11. Now I gave you the one to use in the project, so you gotta use that one. Okay, this one I'm gonna use for my own. After I'm gonna clear this, so I'm gonna equals round between. It will pop out here. Make sure you're seeing this. Okay. Once it pops out, double click on it. Type 5, 11. This is for mine, your own. Use the number that I gave you in Excel. Don't forget that. This is my line. Okay. Press enter. Sorry. Use the number I gave you in the project instruction. Okay. Then I can now either copy. You see this tick cross. Once I bring it close to this place, it's changed to a skinny cross. Once it's changed, double click on it. It will bring all defective. So you have now generated defective. But notice one thing. This number that you generated using round between, they keep changing. Like if you type something else here, let's say you type something, let's say you type 1 here. I want you to watch it. See, it will change. So each time you put something new, it will change. To stop it from doing that, this is what you're gonna do. Highlight all of it, all the way to the last one, 20. Right click on it. Choose Paste Special. Then give me 1 minute. Let me do it again. I think I click on something. Right click on it. Paste Special. Let me see why he's doing this. Okay. Yeah. Paste Special. Okay, let's see. Okay, why is doing that? Undo. Oh, it's because I copied something before. I'll give you 1 minute. Let me clear this thing. I copied before. I'm gonna open a page here. Okay. Let me clear this thing first. Okay, let me clear this. And then, all right, let's see why it's doing that. Shouldn't be doing that. First, yeah, or this one. Okay, let's see. I think I know why it's doing it now. Let's go back. Okay, I'm gonna click here. All right. I believe you can see it now. So right click on it. I mean, highlight all of them. Okay. Now do Control C. Okay. Once you do Control C, right click on it again, then click on Paste Spatial. Once you click on Paste Spatial, this dialog box will come out. Then click on Values. Then click OK. Now, once you do that, now remove the copying. It will stop. It will no longer change. So if I type something here now, it won't change anymore. If I type anything at all, see, it doesn't change anymore. It is now static. That's how you make it static. Otherwise, it keeps changing, and that will mess up your answer. Okay. Make sure you do this. Okay. Now, having gotten the defective, the sample size, we are still to use one in the question. In my own question, they say use 150 bed sheets and 20 consecutive days. So I'm going to put 150 there. Now, it doesn't have to be the same sample size. It can be different sample. It might be 120 today, and then another day 220, another day 80. But for this question, sometimes some people like to keep the sample size to be to use the same number of sample size for all of them. Doesn't matter, just the convention they want to do. My own is 150, so I'm gonna put 150. Yours might be not is not 150, it's a different number. You gotta use that. So I'm gonna, copy it down, change it, double click on it, goes down. Okay, 150. So with this now, we need this to calculate all these things that we need to do. First of all, we need our total, okay? Total. Yeah, let me type what you need to calculate before I can draw this P charts. Now, other total, what else do we need? We need P hats. P hats. When I say P hat, I will show you what I mean by that. I cannot put the formula here, but put it right. It won't allow me to put the bar on it. Not P bar, P bar. Sorry, my mistake. P bar. Won't allow me to put the bar on top of the small p, so that I have it here. See the formula for P bar right there, P bar, okay, and Q bar, okay. So we got a P bar, and we need Q bar, we need N bar, okay. So now we need to find the UCL upper control limit. Then we need the lower control limit. So let's find the total. So let's find the total for this one, okay? Total will be equal sum. It pops out, double click, then highlight from the first to the last, the first 20th, okay? To 20th. Close the parenthesis and press the enter key. 163. Now you can one thing that they said, if you calculate one of them, you can drag it down to calculate the other one. So you just drag it down, calculate this, 3,000. Okay, good. Now with that, you can now calculate the P bar. P bar, the formula is right here. That is the proportion, okay? Say total number of defective divided by total number sampled. So our P bar becomes equals total number of defectives. See the defective right here and to the sample size. So once the 3 divided by, of course, that forward slash is division symbol in Excel, so by 3,000, I give it P bar. Normally we make it 3 decimal places, but we're coming to that. Now for Q bar, we have P bar. Now we can now move it away. Let me move it away. Let's calculate Q bar. Okay. Q bar, as you can see, is 1 minus P bar, okay? It's 1 minus P bar. So it's gonna be equals sign. Okay. 1 minus P bar. Then N bar. So we have this calculated. So we're gonna N bar. Maybe put it right back here. So N bar, we can calculate it using this formula here. That is the average of the ends. Okay. Average of the sample sizes. You can get that one by doing this using this Excel formula here. Okay. N bar, just average, type average equals average, AVA, double click, highlight all the sample sizes. Okay. They're all highlighted. Close it and press enter key. That's 150. Then now with this, we can now get our upper control limit and lower control limit. So let me remove this. So we can get our upper control limit and lower control. So this is the formula for upper control limit. I'm going to move it up. So we will be looking at it as we calculate it. Okay. Upper control limit. I see P hat plus 3 times square root of P hat, P bar times square over N bar. So you have equal. Hope you are ready. This is really easy. So you have it equal, right? P hat is right there. Okay, it's right here. Let us make it, before we start, let us make it 3 decimal places, okay? Highlight it, make it 3 decimal places. Okay, good. Let's do it now. Equal. First one is the, make sure I've seen this. Okay, good. This one is the P hat, which is right here. P bar, hat. Plus, then put parentheses before I type in this 3. 3 is part of this formula, so it's a put 3. 3 times say square root of P times Q over N. So for square root, we type in SQRT. It will pop out. That's square root. Double click. Excuse me. The P hat times Q hat. Click on P hat times click on Q hat and divided by N bar, which is 150. Close the parenthesis. Now you know that we have 2 opening parentheses here. So you gotta close it twice here to balance it. Then press the enter key. Okay. Now that's upper control limit. Lower control limit is equal. The same formula. I said that here we have gonna have put minus sign. P bar minus then parenthesis. Type in 3 times the square root of P hat P bar times Q bar N bar. So type SQRT. Double click. P bar times Q bar, okay, divided by N bar, which is 150. Close it. Again, notice that there are 2 opening parentheses. this one here and that one. Then you have to close it twice to balance it. Press the enter key. Oh. So it's a negative. Now when it's a negative, we just change it to a positive, really, because you don't have negative defective. So anyway, in any case, let me just make it um, 3 decimal places. So it's a negative value. So just put 0 there. If negative, just put 0. Okay, because it's too small. A control limit. Okay, just put 0 there. Don't go here. Now, next is to have what else? Your own might not be that negative, just mine is negative. Now we're gonna have well, now we have the upper control limit, lower control. Now we need to calculate the proportion. The proportion this let me repeat lower control limit again. I'm going to use the formula here so that you can see the formula itself. Okay, this is lower control limit. I'm going to bring it back. I'm going to do it again so that if it continues to be negative, that means says we are good. But make sure we don't make any mistake there. See, lower control limit is equals P bar minus parenthesis 3 times square root of P bar times Q bar by N bar. So square root is SQRT, double click it, it will come out. P bar times Q bar over 150. Close it twice, like I said before. So negative, so we are good. So just make it 0. Can be negative. You cannot, we don't go below defective. I don't know how to say it. Now we have this, we can now calculate our proportion. Now I'm going to remove this. So we get our proportion back. The proportion formula is right here. Move it up. You can see right here. Number of defective by sample size. So that means from here, equal. Click on the number of defectives right here, divided by sample size, which is sample right here. Press the enter key, and then copy it down. It will calculate the rest of them, make them 3 decimal places. Okay. Now we have let's see the center line. We have it here already. P bar is the center line, which is 0.054. Type it in. We have already calculated it here. So type it in 0.054. Now, upper control limit is 0.110. Type it in 0.110. Lower control limit is 0. Now we can just highlight all of this so you can copy them all down. See? Now, once you have all this, we have this proportion, we have all this. You can now highlight them and draw the control chart. Highlight all of them. Click on Insert. Choose the line chart right here and choose this first one. You can see the control chart here. Okay. You can see that it is the the process is not under control. You're gonna put the title as this title. You can call this just proportion of these defectives. Proportion of defective or percent of defectives. Can just give it title P chart. chart for, what's the name of my company again? What's the name? P chart for my company's name is Line Tech Textiles Data. Line Tech Textiles Data. Now, here you can just call day. You can put this day of observation. The day was sampling, sample of examination, okay? And that is the control charts right there for you. So you can see why it's a project. You have to generate your own data. In real life, you have to actually physically inspect the base sheet or the process and collect the data on number of defectives. But we are not in the industry here. It is a classroom. So you make sure you bring your chart down this, so that the formula will not be blocking it. Then after that, you bring a text box. Bring a text box by the side, make it real as big as you can, and write your interpretation. Okay. Now, if any of this line, you can see the upper control limit, lower control limit. If any of this line move down below the lower control limit or above the upper control limit, that means the process is not under control. Then you have to figure out what is wrong. So here, this one is, they are within the line. None of them crosses away from the upper control limit or lower control limit. So I would say that the process, this is about quality control for which country again? Okay. So each day, the number of bedsheet, okay. Based on, okay, producing logic cutting bed sheet. Okay. So you can say that can say that I'm gonna copy this here. I'll copy it. And put it right here. According to the control charts, to the P chart, Line Tech incorporated production process is under control. Now, of course, you have to format it. Everything should not be bold. They right up to 100 words. What your interpretation of this. I'm not going to tell you what to write. You know what to, when something is under control. You gotta decide that is. For example, you can say, okay, since it's under control, they can guarantee their quality product. They can give their customers guarantees that their each bed sheet they buy is has a good quality, and so on and so forth. Now, if any of this line crosses this, I mean, it's not under control. In that case, you have to figure out which number is out of control for which day that you observe that defect that is out of control, and what the company can do to fix it. Okay, and that's it. That's it, guys. This is my expectation for that project. Thank you for watching, and follow the direction here or the direction in the project itself. Thank you. Bye-bye.